Hello and welcome back to 355 Code, the coding school based in the US for children grades 4 to 12. We primarily teach JavaScript in a fun way using the website CodeHS. And in addition to just teaching JavaScript, we also teach project management so that kids can really get the full package and understand not only how to do the technical elements of the coding, but also to um, build complete projects from planning to execution. And today in this video, I want to kind of talk about the SDLC and also give a practical example. So the SDLC is the software development life cycle, and it's basically a cycle of actions that you take when you're managing a software development project. And the first step is really planning. So you'll want to think about what is the product that we want to make and make sure that it really fits the market that you are planning it for. So this, if I give an example that is a little bit relatable, maybe just kind of asking friends what they think a cool program would be or what they would want done. And then we'll move on to the requirements and analysis. So once I have an idea, I have a vision. Now, what do I need to get this done? Which coding languages will I need to use? Do I need images? Do I need user interface, etc.? And then I really get to design. So how are things going to be arranged in the final version? And then from the design, I can move into implementation, which will really be writing the code itself. And then testing, just making sure that everything works and fixing bugs. Deployment, sharing it with other people and letting them have fun and use what you made. And there will always be some maintenance and improvement. So, after deployment, there might still be some feedback or there will be updates to the code that you'll need to make, or you might want to improve by pushing out an upgrade for your program. And this is really a cycle. So in every code development, software development project, you'll be kind of running through this multiple times in several iterations. So you'll do a little planning, gather some requirements, design, write a little code, test it, maybe even send it out to some people, and then keep on doing this all again until you reach a final product that you're satisfied with. So now that you kind of understand the theory behind it, let's hop over to CodeHS and I'll show you how we can use this kind of thinking and planning practically when we are writing code as a hobby. Hi everyone, so now we talked a bit about the SDLC or the software development lifecycle, and now we're going to take a look at how to actually implement that in one of the HS Code challenges. So to remind you, the first stage of the SDLC will be planning. So planning here is really just taking a look at the exercise itself and seeing what the requirements are. We don't need to do any kind of market research or anything because we're given quite specifically what the task is. So we can really just go straight ahead to analyzing the requirements. So we're going to need to build a Hailstone sequence. So we're going to need to take user input, that's an integer, and we're going to need to be printing out some numbers. So we're going to have an input, we're going to have some kind of function that's executing, and we're going to have an output. So those are pretty much our three requirements. And in terms of design, so we can really see what the final state is supposed to look like here in the assignment explanation. So we see that we have enter number, which is going to be our input. Then we have a long list of numbers that are printed out, and then we have a closing output, which tells us how many steps it took to complete. So we're going to really break our code up into these three parts. And now we can really move on to the development stage, which is actually writing out our code. So let's take a look at the code. And inside here, what we're going to want to start with is our function. So let's everything in each's code needs to take place within this start function. So you could just kind of ignore that and start writing your code in here. So let's say we'll call our function Hailstone, just because that's the mathematical sequence that will be executed. So first of all, let's think about what we want to do. So we want to take a user input. So we're going to be passing our input into this function. So basically, over here, we want to take user input, and we're going to take this function, and we're basically going to execute function and get an output. So let's start with input. So to take an input from a user in HS code, we're going to need to check out the docs. And this is an important part of development because you're never going to remember all the code by heart, but you should have documentation that you can use to look up. So here we find user input, and we want to have an integer. So the user input, let's call it num, right? Because that is what we're going to be passing into the function. And this will be read int. And what we put here between the parentheses is what the user will see when they're prompted to enter a number. And it'll also be what is printed out in the console. So if we check out show exercise again, it says enter number and then colon. So we're going to use that for our prompt here. So enter number colon. Great. And then we have our function. So let's see what we actually want to do here. So we took our number, and this number we're going to want to create a for loop. That is because we basically need to execute a certain function on this number, and then depending on the outcome, decide if we want to continue executing the function or not. So let's start with our for loop. So for, and we're going to need to declare a variable I, and this variable will start out equaling to the number, which is the number that the user passes into the prompt, and is also passed down into the function. And then we want to tell the for loop how long it'll run. Okay, what is the condition under which it will stop running? So if I is smaller than 1, it should stop. And how do I know this? Because in the requirements, we see that continue this sequence until you get the number 1. And because basically I is going to be equal to the number itself, we just want to know when it's going to be smaller than 1, and then we're going to stop executing this. And now we want to put in our conditions. Okay, so basically, what are the changes that we'll be making to I in different situations? And because we have 2 different situations that are depending on the user input, we're going to have to use an if statement here. So let's open up the if statement. And for the last part here, we're going to want to say what happens to I at the end of each time this loop runs. And basically what we're going to do is we're going to change the value of I to a new number, which we are going to change based on the requirements. So basically what we want to do now is right, what will happen each time our for loop executes. So here we have two different outcomes for two different conditions. So if n is even, then we divide it by 2. So if I, because that is the number that we are checking each time, is even. So how do we check that? We can use this to see if there is any remainder after dividing by 2. And if that equals to 0, which basically means that it's even, then we are going to want to divide the number by 2. So we're going to say new number equals I divided by 2. And then we are going to want to print the new number. And then we finished this first part of the exercise. And now, what do we want to do in the second condition? So else, okay, because we basically only have two situations here, one if it's odd and one if it's even. So else, so if it's not even, it'll definitely be odd. We don't need to add another condition here. And if it's odd, then we want to multiply by 3 and add 1. So then in that case, new number will be equal to I times 3 plus 1. And again, we were going to want to print, so we'll just copy that from over there. Great. And now we're done with the second condition. So I'm going to take this down here outside of our function, but on the bottom, just so that we can execute it right before we call our function. And what we're gonna pass into our function is this number, which is what the user enters. So let's test out our code. So output and run, we get a prompt, and here I'm going to enter the number 17. And so we got a error. So what I'm going to do is I'm going to put some parentheses here, and then try to run it one more time. And that didn't help, so let's take a look. So this stage is actually a very important part of the SDLC. It's the testing phase, so we're basically testing our code to find any bugs. And we already found some bugs because basically our code is not executing as we expected. So when we're debugging, we're just going to want to look over our code and see what might be wrong. So we know that the for loop is not really executing, right? Because we printed our enter number, we printed our prompt, but nothing is happening really inside our function. So it could be that the function isn't executing at all, and it could be that there's a problem with our for loop. So let's take a look at the for loop, and if we take a look at it, then we'll see that we told the for loop to execute as long as I is smaller than 1. But we actually wanted it to run when I is bigger than 1. Because if we only do when I is smaller than 1, then if you enter any number that's above 1, it won't execute at all. So now that we fixed that, let's try running it again. And we'll enter 17. And we have all of our numbers printed out. But we only have one thing missing, which is the final requirement of it took how many steps to complete. So basically what we're going to want to do is after the for loop is done, so let's look for this right here. So after we exit the for loop, we're going to want to print a line. And these print line and these read int, these are all special functions that are unique to CodeHS. They're not pure JavaScript. So if you're curious about them, you can really read up more in the docs of CodeHS. And what we're going to want to print here is really what we got here in our requirements. And let's turn that into a string. Let's not forget spaces. And here in the middle, basically what we're going to have is a variable. And let's call that variable count. And this is basically how many rounds we went through here. So how are we going to know that? Basically what we can do is we can declare a variable count right up here on top when the function starts running. And then each time we run through our for loop, we will add 1 to count. So we have to remember to put it both in the if and the else, because only one of them will be executing. So basically we declare count, and then every time we run through this loop, we add 1, right? Plus plus means add 1. And then at the end, we print it right here before exiting the function. So let's try that again. I'm going to clear and run 17. And we have another bug. So this is another stage of testing within our development cycle. So let's try and figure out why we did not manage to print the count. So as you can see up here, when I declared the variable, I did not really give it any kind of value. So let's try giving a value to var, the var count, before we start running. And we'll clear that and run again. And 17. And now we see that count says it took 12 steps to complete. So that finishes our development stage. We have the working product, so now we can really deploy this to the world. We can put it on our website or send it to our friends and let them have fun and enter whatever number they want, and it will execute the Hailstone for them. And we can also get some of their feedback. Maybe they would like to add some cool features, like entering multiple numbers or some other weird version of Hailstone. And that really sums up our video about the software development lifecycle. I hope this helped, and hope to see you on one of our 355 code lessons. Just to remind you, we give free trial lessons every day at 5 p.m. You can head over to our website, 355code.com, to sign up. And you can also